This is a short lesson on transforming formulas that we've already done in class, but you're going to see this. The objective here is to take these things called formulas. A formula would be something like distance is equal to rate times time. They have mostly variables in them, and what we want to do is change the order. Or in a sense, what we're going to do is to isolate a different variable in a formula. Maybe I want to take distance is equal to rate times time and instead solve it for r, not d. Right now it's solved for d because it's a d equals. D is by itself. And since d is by itself, what I really want to do is I really want to get r to be by itself. So we're going to make d not be by itself and get r by itself. In order to do that, let's actually make this example 1. We're going to start with d is equal to rt, and we are going to solve for r. Okay. Right now, distance, rate, and time could be anything. This is distance is equal to rate times time. And if I want to get r by itself, I have to realize what operation is between r and t. That's a times. And how we undo times. We undo that with division, or multiplying by the reciprocal. So I'm actually going to take this and rewrite it. Now distance equals rate times time, but I'm going to put a fraction bar on both sides of the equal sign. And because it's a times in between there, and I want to get the r by itself, I'm going to divide by the thing that's not the r. I'm going to divide by t. And if I divide the right side by t, I have to divide the left side by t. And I end up with d over t equals r. And that's it. We've done it. We've isolated r. It's the same equation, just a different form. And that's important to note, that this is a different form of the same equation. I haven't changed anything other than where things are, but it's the same idea. Now, it's also important to note that because of the way I've changed this, I now have a t in the denominator. I actually now have a variable in the denominator. So I need to state that that variable t cannot be equal to 0 if this equation is going to work. So my final solution, or my final answer, is what I'm highlighting right now. It's r is equal to d over t, but then stating that t cannot be 0. Let's move on. Each of you should have an idea of what surface area means. And I'm not asking you to memorize any formulas just yet. That will come in some later courses. But surface area, here's the surface area of a square pyramid. If I kind of just draw a square pyramid, and I'm not terribly good at drawing these things, but I will do my best. Okay, that was not too bad. If I draw a square pyramid, okay, that's kind of good and bad. I could label the base as having sides of s, and then the slant height is what we call it, this thing here. I could call that r. And the area of that thing, the surface area, is equal to, we have the base of s squared plus, and I have 4 triangles, 4 times 1/2 base times height, which would actually give me 2 times rs. Now, don't worry about that, but what I want to do is I want to take that and I want to solve it for this variable that I'm going to put now in red. We're going to solve it for r again. It's a different kind of r than what we just did. I'm going to take this and I'm going to solve it for r. To do that, I have to get the r by itself. And to do that, I want to get this entire term here by itself. And to do that, I have to subtract the s squared from both sides. So I'm going to go minus s squared, and I'm going to have a minus s squared is equal to 2rs. Now, as a side note, I want you to know that 2 times r times s is equal to 2 times s times r, which is equal to r times s times 2, which is, so on. We can change the order of multiplication. One thing that's sometimes helpful for people to do is to put these in parentheses, so you can see really that you have 3 things being multiplied, and we want to get rid of 2 of them. I want the r by itself, So I'm going to take both sides and I'm going to divide it by the pieces we don't need. Again, since it's all multiplication, I'm going to divide it by 2 times s. And over here I'm going to divide it by 2 times s. I'm just going to write it as 2s. And so when things divide out, they become the number 1, so the 2's go away and the s's go away, leaving behind the r that is sandwiched in there, but it is still there. It's still alive and kicking. So we have r equals a minus s squared over 2s. And again, since we have a variable in the denominator, that variable cannot be equal to 0. So what I'm going to say is s cannot be equal to 0. And that's it. Number 3, if I have v is equal to pi r squared h, that is the formula for a volume. And what we have to do is, first we have to say, well, what variable do you want us to get by itself? Let's say we want to solve this. Here, I'll put solve for h. I'm going to rewrite this one more time. I'm going to write it with parentheses. Pi times r squared times h. And I want to get the h by itself. So I'm going to divide both sides. Again, because this is multiplying, I'm going to divide it by pi. So I'm going to have a pi over here. And then I'm going to divide it by an r squared. So I have an r squared over here. And the pi's are going to go away, and the r squareds are going to go away. Flip the order, and I have h is equal to v over pi r squared. Oops. And that's it. Oh wait, except the r squared. Now, don't say pi can't be equal to 0. I know pi is not 0. Pi is 3.12159, and or 3.14159, and so on. Okay. But if r squared is not going to be equal to 0, that means that r cannot be equal to 0. Number 4, this is a very common one in chemistry. PV is equal to nRT. Pressure times volume equals number of moles times the gas constant times the temperature in Kelvin. And we're going to take that and we're going to solve it for T. So, divide both sides by nR. Divide by nR. And I get PV for nR is equal to T. Now, I am just going to say that n cannot be equal to 0. You can say r cannot be equal to 0 too. I know that r is a constant, and r is a value of 0.08206. If up here I were to say r equals 0.08206, then you would know that you wouldn't have to say anything here because we know r is not equal to 0. So I'm just going to kind of leave it like that. For number 5, if I say s equals 2 pi rh plus 2 pi r squared, and I want to solve this for h. So again, I'm going to look and see the h is in this part right here, which means that this part needs to get subtracted over to the other side. And I can subtract the entire group together. So I get s minus 2 pi r squared equals 2 pi rh. Then I'm going to say I want the h by itself, so I'm going to divide the left side and the right side by a 2 pi r. 2 pi r. And I end up with s minus 2 pi r squared over 2 pi r equals h. I'm going to put a comma and look at the denominator. 2 can't equal 0. Pi doesn't equal 0, but I have to say r can't be 0 because that's a variable. We're done. 6, I have s is equal to r over 1 minus r. And I want to solve that for r. Well, I have 2 r's now, so this is going to be a little bit tricky. What I'm going to have to do is do a little cross product to get this out of fraction form. So I'm going to do s times 1 minus r equals r. Now, remember, to see how I got that, I kind of have to go back to this. This is s over 1. And remember that if two fractions are equal, their cross products are also equal. So I end up with this. Now I want to get r by itself, but I have r on both sides. Let's do the distributive property. Do s times 1 and s times r. So I get s minus sr equals r. And I want to get my r's on the same side, so I'm going to add sr to both sides. I have s equals r plus sr. Now, in order to answer this one, what I have to do is get the r by itself. I'm going to put parentheses here, and I'm going to undistribute the r, which is another word for that is factor. I'm going to pull the r out, leaving behind a 1 plus s. And if you were to multiply the r back in, you would see that these two are truly equal, that r times 1 and r times s would give me that again. Then, as a last step, I'm going to divide both sides by a 1 plus s. That's going to go away, and I'm going to end up with s over 1 plus s equals r. Furthermore, because I have 1 plus s in the denominator, it's not that s can't be 0, s could be 0. I can't have 1 plus s be 0, so the number that s can't be would be the number that I'd plug in that would make 1 plus s be 0. If I don't want 1 plus s to equal 0, that means s can't be negative 1, because 1 plus negative 1 is 0. And that's what we get. Okay, let's do one more. I have q equals t over 3 minus s. I'm going to want to solve this for s. So what I'm going to do is I'm going to do cross product again. This is q over 1, so I have q times 3 minus s equals t. Now, I could distribute that. I don't have to. If I did distribute it, I end up with 3q minus 3, or sq equals t. And then I want to get the s by itself, so I'm going to subtract a 3q. And you get negative sq is equal to t minus 3q. Now, one thing I'm going to do right now is I'm going to multiply the left and right sides by a negative 1 to change all the signs. sq is equal to negative t plus 3q. That way, I can kind of switch the order around on the right side and make that 3q minus t. It's going to make things just look a little bit easier, and then I can divide both sides by a q. I get s equals 3q minus t all over q. And I'm going to say q cannot be 0, because that's in the denominator. Okay? Now, I'll let you look online for what your homework is. It's a book part and a worksheet.